And now let's look at the standard notation for the other type of insurance. So for annual term, we have a standard actual notation. So you can see that this is the same as the premium, but the only difference is that for the premium, we use P, here we use V, and for V, we also need to specify the time of the reserving. So we are looking at the time K now. So we put a K in the subscript to the left of capital V. And this is just difference between the APV of future benefits at time K. At time K, for this annual term, the future benefits will be just N minus K years of term to a person aged X plus K. And the future premium will be annuity due starting from time K until time M. So that's N minus K years of term of annuity due to a person aged X plus K, multiplied by the annual amount of payment, which is the standard notation for the net premium for the annual term insurance. And when K, if we are looking at the reserve at a time that's greater than or equal to M, then there'll be no reserves at all, so it's 0. And we can also consider the case where we restrict the number of payments of the premium to H years only. So in this case, we add an H in the subscript to the left of V. In such a case, if H is greater than K, so that means at time K, there is still future premiums, and the term of the premiums is H minus K year term. So in this case, the APV of the future premiums will be just annuity due with H minus K years of term to a person aged X plus K, and multiplied by the annual amount, which is the standard actual notation for an H pay whole life. That's a capital P with an H in the subscript to the left of capital P. And in this case, the future benefits will be just whole life insurance to a person aged X plus K. So that's capital A X plus K. And the difference between this one and the APV of future premiums, that will be just the prospective loss. And if K is greater than or equal to H, there'll be no premiums payments. So there's only future benefits. We just keep the future benefit term, which is capital A X plus K. And we can also consider H year pay and year endowment. So the notation here is very similar to the H pay whole life. So we use the subscript and subscript to the right of V to represent the insurance type. And here it's endowment. And if we are considering a K that's smaller than H, then there'll be future benefits and future premiums. The future benefits will be endowment from time K until time N. So that's an N minus K year term endowment to a person aged X plus K. And for the premium part, the premium is payable until year H. So the term of the premium will be from time K until time H. So this is a H minus K years of term of annuity due to a person aged X plus K. And this should be multiplied by the annual amount of payment, which is an H pay N year endowment. And if K is greater than H but smaller than M, then there will be still future benefits, but there will be no future premiums. So we only keep the future benefits. And if K equals M, recall that the pure endowment benefit of an endowment is considered to happen right after N. So we need to reserve the amount of pure endowment at time N. In this case, is $1. Now let's look at a numerical example. So let's consider the following survival model with QX being 2% and QX plus 1 equals 3% and QX plus 2 equals 4%. And we assume that V equals 0.97. Now we need to determine the net premium and also the prospect reserves for this special 3-year term insurance. And the payments, the benefit amount of this insurance is $10 in the first year, $20 in the second year, and $15 in the third year. So let's first try to calculate the net premium. Net premium is determined by using the equivalence principle. And to use the equivalence principle, we need to find the APV of premiums at time 0 and APV of benefits at time 0. And then by equating these two together, we will obtain an equation. By solving the equation, we solve the net premium capital P. Let's use capital P to represent the level annual premium. Then the actual present value of future premiums will be just $1 at time 0. That's certain. $1 at time 1 if the policyholder is alive. So that happens with probability P. And $1 at time 2 if the policyholder is alive at time 2. So that probability is 2-year survival probability. And the present value of $1 is V squared. And add all these three terms together. That's the APV here. And this is the so-called current payment technique formula. And now for benefits. So let's consider the first payment. The first year payment will be at time 1. And that payment will be payable if death occurs in the first year. So $10 is the amount of benefit. V is this is amount. V is the discounting function, discounting, and the condition is the death, and that has probability QX here. So probability. So usually the amount times discounting times probability gives us the present value, and that's for the first year. And let's consider the second year. During the second year, there will be a payment of the death benefit. $20 at time 2. So 20 is the amount, time is 2, so the discounting is V squared. If death occurs in the second year, so death occurs in the second year is a probability that capital T is between 1 and 2. So that's just a 1 year probability of death. And for the third year, a benefit of 15 will be payable at time 3 if death occurs in the third year. So that's 15 times V3 times the 2-year survival probability. That's the probability that death occurs in the third year. Okay, now we just use the information on Q. So it's 10 times V. V is given in the question. That's 0.97. And QX is 2%. And plus the second term 20 times V squared times the 1 year deferred probability of death. 1 year deferred probability of death equals 1 year survival probability times 1 year probability of death at age X plus 1. And this is equals 1 minus QX times QX plus 1. And both QX and QX plus 1 are already given in the question. So we can easily find this 1 year deferred probability of death. And for the last term, it's 15 times 0.97 cubic times 2 year deferred probability of death. And that's the 2 year survival probability times 1 year probability of death at age X plus 2. And the 2 year survival probability equals the multiplication of 1 year survival probability, that is Px, times Px plus 1. And then we copy the last term, which is Qx plus 2. And all the P's equals 1 minus Q, so it's 1 minus Qx times 1 minus Qx plus 1 times Qx plus 2. And all the 3 Q terms are already given in the question, so we can calculate the 2 year deferred probability of death. And this way, we found the APV of benefits. And the equivalence principle says that APV of premiums at time 0 equals APV of benefits at time 0. So by equating these two together, we get the equation for P. And by solving this equation, we obtain the numerical value for P. So that's the net premium. Now let's look at the reserves. So let's start from time 0. At time 0, there's reserve is 0. Because reserves, prospect reserve is just difference between the APV of benefits and APV of premiums. And because premiums are determined by the equivalence principle, so at time 0, the difference between these two is 0. Now at time 1, the prospective reserve is defined to be the APV of future benefit at time 1 and APV of future premiums at time 1. at time 1, this is time 1, 2 and 3. So there's 2 years left for the term. And in the first year, which is from time 1 to time 2, there will be a benefit of $20 if death occurs between time 1 and time 2. And at time 3, there will be $15 of benefit if death occurs between time 2 and time 3. So the first payment will be $20 at time 2 with a probability of death between 1 and 2. And because for the reserving calculation, we are conditional on the survival at time 1. So given that the person is alive at time 1, the 1 year probability of death is actually 1 year probability of death of a person aged X plus 1. So the probability times the amount of 20 times the discounting, which is 1 year discounting, that gives the APV of the benefits in year 1. And in year 2, which is from time 2 to time 3, the amount is $15, which is payable at time 3. And the discounting will need to discount this money from time 3 to time 1. So that's 2 years of discounting. And the probability that the person dies between 2 and 3, given that the person is alive at 1, that's just 1 year deferred probability. So add these two together, we got the APV of future premiums, future benefits at time 1. And for future premiums, we're going to use the P that we obtained before. So we use the premium that's determined using the equivalence principle. And that's the annual amount of premium. That annual amount times the APV of annuity due here. So there are 2 years left. So this is 2-year term annuity due. And that's just 1 plus time 0. That's 1, the payment, possible payment at time 2. That's V times the probability of survival to time 2, given the person is alive at time 1. So that's just 1 year survival probability of a person aged X plus 1. And for the reserves at time 2, similarly, we consider the future benefits and the future premiums. In this case, there's only 1 year left. So time 2 and time 3, there's an amount of benefit, $15 payable at time 3 if the person dies within 1 year. So the probability here is actually the conditional probability that capital T is between 2 and 3, given that capital T is greater than 2. So this is just basically a 1 year probability of death of a person aged X plus 2. And the discounting is just 1 year discounting. And for the premiums, there's only 1 premium at time 2, which is certain. So there's just a P there. And this way we found the reserves at time 2. And at time 3, there'll be no benefits, no premiums. So the difference is always 0. So the reserve at time 3 is 0.